Okay, guys, in this chapter, we're going to start talking about factoring. And factoring is the single most important thing that you need to be able to do well to succeed in this course and college algebra. So if you have any trouble at all, practice this. And if you need help, let me know. Okay, so what factoring means is to factor a number means to write it as a product is multiply, of two or more numbers. So this is 12 written in a factored form, right? But think about this. We could also write 12 in these forms, -6 times -2, 3 times 4, etc. So we want to make sure that there's one standard way that everybody's going to write it in the same factored form, and we're going to do that by writing it as factored primes. Okay, and remember what a prime is. A prime is a number that's only divisible by 1 and itself. It doesn't have any other factors, right? So right here, we could separate that 6 to 3 times 2, and here the 4 to 2 times 2. Can't do that here. If you were asked to write this as a prime factored form, everybody would get the same factors. They might be in a different order. That's okay. 2 times 3, 3 times 2, same thing. Okay? But we'd all have the same factors. Okay, so the greatest common factor. An integer that is a factor of 2 or more integers is a common factor. For example, 6 is a common factor of 18 and 24 because 6 is a factor of both 18 and 24. Other common factors of 18 and 24 are 1, 2, 3. The greatest common factor, though, GCF, that's going to be important to us, is the biggest of all of those common factors. So 6 is the greatest common factor of 18 and 24 because it's the largest of all the common factors. No other number divides evenly into both 18 and also 24. Okay, so to find the greatest common factor, first we're going to write each number in its prime factored form, and then we're going to list the ones that are common to each one. Okay, choose the least exponents if you have it written in an exponential form, and then multiply those primes together. So there's some steps you can read over, but let's just get to it. Okay, before we get to it, here's some helpful divisibility tests, right? If we're going to be finding numbers that divide evenly, aka factors of these numbers, then it helps to have divisibility tests. We probably know 2 and 5. If a number is divisible by 2, it's got to end in an even number. If it's divisible by 5, it's got to end in 0 or 5. But it's useful to know some of the others also. If a number is divisible by 3, the sum of its digits is divisible by 3. If a number is divisible by 4, as long as the last 2 digits are divisible by 4, the entire number is. And here's one for 6, it's even, divisible by 2, and divisible by 3. 8, that one's not really useful because it's kind of hard to divide the last 3 digits anyhow by 8. But if you have a giant number, it's easier to divide 3 digits than 4 digits or 6 digits. 9 is similar to 3. If the sum of its digits is divisible by 9, then that number is divisible by 9. So just as let's take a number. 1,235,632. And I want to know if this number is divisible by 2. Yes, it is because the last digit is divisible by 2. Is it divisible by 3? I don't know, but I can tell pretty quickly. Let's add these up. 2 plus 3 is 5 plus 6 is 11. Plus 5 is 16. 17, 18, 19, 20, 21, 22. Note the sum of the digits is 22. 22 is not divisible by 3, so this entire number is not. Is it divisible by 4? I don't know. Are the last 2 digits divisible by 4? Hey, 32 is divisible by 4. It's divisible by 4. Okay, it's not divisible by 9 because I already added up the digits, and 22 is also not divisible by 9. And it's not divisible by 10. It's not divisible by 6 because even though it is divisible by 2, it's not 3. So that's what those mean. And we'll use some of them. They'll be really useful. So find the greatest common factor for each list of numbers. Okay, so what we want to do, and sometimes when we're dealing with numbers, we'll automatically know. Some of you may be able to look at this and know it's 25. So that's fine. If you can't, here's a method you can always use. You find the prime factorization. Okay, so remember our factor tree. I'm going to make this 5 times 10. I could have written 25 times 2. It doesn't matter. Any two numbers that multiply to give 50. Okay, if one of them is prime, I'm going to circle it. Now I can write this one as 5 times 2. Any of them that's prime, I'm going to circle it. So 50 is 5 squared times 2. Let's do the same thing for 75. 75 is 3 times 25 because this is prime. And look, 7 and 5 is 12, so I know it's divisible by 3. Some of you might have started with 5, knowing it's divisible by 5. Whatever. 25 is 5 times 5. So I can write it in its factored form as 3 times 5 squared, right? 2 5s, I can do this. Okay, so anything they have in common. Notice they both have, let's do this. Notice they both have a 5 squared. So I'm going to take that. There's nothing else in common, so this is their biggest common factor. Notice 5 is also a common factor, but the biggest one is 25. All right, so let's try it with some numbers that we may not have known the answer to. Okay, let's start with 12 and find our prime factorization. Let's make that 3 times 4, and then 4 is 2 times 2. So 12 I can write as 2 squared because there's 2 2's and a 3. Let's do the same thing for 18. I can write that as 2 times 9 or 6 times 3. It doesn't matter. 9 is 3 times 3. Just whichever factors you think of first. So this one is 2 times 3 squared. Okay, 26 is 2 times 13, and those are both prime. And 32 is, let's say, 8 times 4. And this is 2 times 4. And this is 2 times 2. And 2 times 2. So 1, 2, 3, 4, 5 2's. All right, so I'm looking for what they have in common. So this one has some 2's and some 2's and some 2's and some 2's. They don't all have 13's. They don't all have 3's. Now, I picked the smallest exponent. So my answer is just going to be 2, right? Because this has a 2 in it, but this one does not have a 4 in it, right? So you always pick the smallest exponent for your greatest common factor. Okay, let's do it one more time. 22 is 2 times 11. Those are both prime, so I'm done with that one. 23. I'm done with that one. It's a prime, right? It doesn't have any factors. And what about 24? Okay, 6 times 4 maybe. 2 times 3. Those are both primes. 2 times 2. So this has 2 cubed times 3. Now, this one doesn't have a 2, even though these do. This one doesn't have a 2. They don't all have an 11. They don't all have a 23. They don't all have a 3. If there's no other number in common, then their greatest common factor is a 1. And these things are called relatively prime to each other. In other words, they don't have any factors in common besides 1. We don't need that term relatively prime, but just for your information. Okay, now look at these. Now we're introducing variables also. But remember, they're all the same variable. So I just take the one with the smallest exponent. So if we need to go over and find and do our factor trees to find the greatest common factor between 16, 10, and 8, we can do that. Most of our numbers we should be able to look at, and I know that 2 is the greatest common factor in these. If I'm not sure, do your factor tree. But 4 doesn't divide into 10, and neither does 8. The only factor they have in common is a 2 for all the numerals. Now they all have an R, so I'm going to take some R's. I just have to figure out how many, and it's always the smallest exponent. So that's your greatest common factor. Now down here there's no numbers except 1, so that's my numeral. They all have some S's and they all have some T's. I just have to figure out what's the most that they all have in common. Let's see, this has 4 S's. Oh, this one only has 3. That one has 9. So S cubed, the smallest exponent. 5 T's, 2 T's is the smallest amount of T's. So that's the most that each one has as a factor. Okay. We're going to build quite a bit in this section, so keep up. Okay, factoring out the greatest common factor. Okay, so factoring a polynomial, which is our goal here, is a process of writing a polynomial in factored form as a product. So instead of writing it as 2 things being added, our goal is going to be to write it as 2 things being multiplied. So here I've got 3 times this m plus 4 thing, whatever it is. It's the 3 times this thing instead of 2 things being added. So what we do to do that is we look at the 2 terms individually and find their factors. Right? They both have a factor of 3, so I can pull it out. Then you always put a parenthesis, right? As soon as you write the greatest common factor, your next step is you put a parenthesis. And then you put what's left of the factor. So 3m, if you remove the 3, there's going to be an m left. And if you factor a 3 out of 12, or you divide a 3 out of 12, there's a 4 left. Okay, and then you close the parenthesis. So here's the factored form of this binomial. You can always check your factoring by multiplying it back out and making sure it works. 3 times m is 3m, and 3 times 4 is 12. Did you get the exact same thing? Yes. So we can check our factoring. And factoring is going to be the most important thing. We got to be able to do well. Okay, so let's practice that. Okay, remember, let me say one more thing. Remember, when we had the 12, we said here's its factored form. A bunch of things multiplied together, but it still equals 12. So it's the difference of, is it just asking you what's the greatest common factor, or write it as its factored form? Okay, so now it's asking us to write it as its factored form. So I got to pay attention to the two terms. And I'm looking for the greatest common factor of this term and this term. So let's do the numbers first and then the variables. So 6 and 12, what's the biggest number that divides into 6 and also 12? Yes, a 6. Okay, they both have an x. I just have to figure out how many I can take out. It's always the smallest exponent. Okay, so just one. After you get, now, if the question said, find the greatest common factor between these two terms, that's it. But this says write it in factored form. So I've got to rewrite this so it equals the same thing, it's just in a different form. So when I'm doing that, my next step is to put a parenthesis, and then the remaining factors go in here. Okay, 6x to the fourth divided by 6x. Or what if I take the 6 out and one of these x's, it's going to leave an x cubed. Got a plus sign, so it'll stay a plus. What if I take a factor of 6 out of 12? What's the other factor? A 2. Okay, or 12 divided by 6, however you want to think of it. Okay, I took the whole x out. I didn't leave any of them. It's right here, so close your parenthesis. There it is in its factored form. And I could always check it by multiplying that out and making sure I wind back up with the same thing. All right, this time I've got 3 terms. So numbers first, 30, 25, and 10. Okay, let's see a 5. Also, I could just keep going. Let me show you what we're talking about. But I don't want to spend a lot of time figuring out what that greatest factor on that number is, because I'll show you something. Okay, I think it's a 5. I might not be, there might be something bigger, but I'm thinking 5. Okay, so now I'm going to look at the variables. Okay, I've got a t to the 6th, to the 5th, and to the 4th. The smallest exponent's that 4th, so I'm going to say t to the 4th. Then you put your parenthesis after you have your greatest common factor, and your remaining factors go inside the parentheses. So 30 divided by 5, or factoring a 5 out of 30 leaves a 6. T to the 6th divided by t to the 4th, that's going to leave 2 t's, right? Or if you factor 4 t's out of t to the 6th, it's going to leave 2. There's a minus sign, so that stays a minus. Factor a 5 out of 25 leaves 5. Factor t to the 4th from t to the 5th, that's going to leave 1t. Now there's a plus sign. Okay, factoring a 5 from 10 leaves 2. And I took the whole t to the 4th, right? This whole t to the 4th out to the front. So there's no t's here, so close your parenthesis. Now, here's a quick check to make sure that is really my greatest common factor. Look at your numbers. Hey, they don't have any factors in common. Look at that 5 and 2. So I'm confident that that is my greatest common factor, that 5. It's the same thing as thinking about reducing the fraction, let's say 10/20ths, and reducing it to 5/10ths, okay, and realizing, oh, they still have something in common, so I could keep going. Same thing here. I could factor out a common factor that I see, and then just make sure that I can't take another factor out. Okay, 2 terms here. I don't have any constants or coefficients, I guess I should say numerals or coefficients. So only the variables. The smallest exponent is r to the 10th. So if I pull a r to the 10th out of this r to the 12th, it's going to leave an r squared. And if I pull this r to the 10th out front, it doesn't leave a 0, it leaves a 1. Remember, when you multiply it back out, you got to wind up with what you started with. If I thought this was 0, when I multiply it together, all I'd get is r to the 12th. So when you completely factor something out, it leaves a 1. Just like here, that x completely left, it's really a 2 times 1, right? The 6 completely factored out of here, there's really a 1 here. So here I've got to write the 1 because there's no other placeholder there. All right, let's do that one more time. All right, this time, first of all, we got to figure out just how many terms we're dealing with. Remember, terms are separated completely by plus and minus signs. Completely. That's going to be important. So my numerals, between 8, 16, and 12. I'm thinking that's 4, so let's try that. Let's see, this one has p to the 5th, p to the 6th, p to the 4th, the smallest exponent. They do all have p's. Make sure they all have p's. If this one didn't have any p's, I couldn't factor p's out of any of them, right? Okay, q squared, q cubed, q to the 7th, q squared is the smallest exponent, and they do all have q's. And then you put your parenthesis. 8 divided by 4 is 2. Okay, it's a p to the 5th, but there's p to the 4th right here, so there's only one p left in there. There's not any q's left in there. I've pulled them all out. Okay, the remaining factor when you divide 4 out of 16 is 4. How many p's are left? Right, 2, because I took 4 out. How many q's are left? 1. Okay, now there's a minus sign, so be careful. Okay, what number goes right here? 3. How many p's? None. They're all right here. How many q's? 5. Okay, 3, 4, 2. They don't have any common factors. They don't all have p's. They don't all have q's. Right, left inside here. So I'm pretty confident that I factored it correctly. Okay. Anytime you have a negative in front of your leading coefficient, you want to factor it out. Even if nothing else factors out, you'll factor out -1. So I know anytime I have a negative in front, it's coming out, no matter what else does. Okay, but 2, 8, and 4, hey, I can also take a 2 out. They all have x's also, so how many can come out? At most 3, right? Parenthesis. Now, this negative out here is going to change the sign of every one of these, right? Because if you divide a negative by a negative, it's a positive. If you divide a negative by a negative, it's a positive. If you divide a positive by a negative, it's a negative. Close the parenthesis. Okay. So again, even if nothing else would have come out, that negative needs to come out. Okay. Now remember what we said about terms. When I'm factoring these, I'm looking at terms, and terms are separated completely by plus and minus signs. This thing only has 2 terms because these are hooked together with multiplication. So when I'm looking at this, I realize, okay, they don't have a common number or an R, but look, they both have a P plus Q. That P plus Q is my common factor. That's coming out. So when I take this P plus Q out, what's left right here is only that 6. Don't forget, first step is put that, after you get your common factor, put that parenthesis. And there's a 6 left. Over here, if I were to take this P plus Q out, divide it out, it would cancel out. Think of pulling it out to the front, whatever. There's a minus R left. And then you close your parenthesis. Now, it's really, really important here to make sure that we don't do this kind of thing. You know, take out that common factor, and then we've got parentheses here, but this is different. This means the only thing getting multiplied by that 6 minus r is the q. Okay, we gotta have parentheses around that first thing. Okay, let's look at it here. Same thing. I really have two terms, and what do they have in common? Yes, that y plus 3 thing, and that y plus 3 has to be hooked together with parentheses. It's like one thing I'm moving around, so I got to keep it in parentheses. Now what's left if I were to take this y plus 3 out? There's a y to the 4th left. Don't forget you open that parentheses. What's left in this last term if that y plus 3 is divided out or factored out, whatever you want to call it? The only thing left is a minus 7. Close your parenthesis. Okay. All right, let that soak in. That's going to be important. Factor by grouping. Now, first thing we always do when we're factoring is we factor out a greatest common factor. Don't forget that step. It's going to get to the point where we hardly have one. So when we do have one, if we forget about it, it's going to mess us all up. So I'm looking and I notice they don't all have numbers. No, they don't all have P's or Q's either. So right now this thing can't factor. If you have 4 or more terms, this is for 4 or more terms only, 4 or more terms. Then I'm going to think about doing something called factoring by grouping. I'm going to separate this into 2 separate groups and think about factoring each one. Okay, so if I'm factoring this one, I'm just looking at these 2 terms. They both have a Q. I can write that Q. Then don't forget, once you get your greatest common factor out of there, you put a parenthesis. What's left here if I factor that Q out? There's a P. Okay, plus sign. What's left here if I factor that Q out? There's a 5. Close your parenthesis. Okay, now there's a plus sign, but now I'm concerned about factoring these 2. Just doing it in groups of 2. Oh, they both have a common factor of 2, looking at the numerals. Once you get your greatest common factor, parenthesis, what's left right here if I factor out a 2? A P. What's left right here if I factor out a 2? And there's a plus sign, a 5. Hey, look, this is where we just were. This is where we just were, right? We said here's 2 terms. What do they have in common? They both have that P plus 5. And what's left if you factor out the P plus 5? Then there's the Q plus 2. Let's check it. PQ plus 2P plus 5Q plus 10. Is that the same thing as up here? Yeah. These are in a different order. That doesn't matter. 2 plus 3, 3 plus 2, same thing. That is the same thing. Here's my factored form. Aha! So now we can factor polynomials with 4 terms if we use something called grouping. Group them in groups of 2. Let's practice it. All right. First of all, look for a greatest common factor. But they don't have any common factor in numbers in all of them. They don't all have x's or y's. So I'm going to try grouping. I'm going to group just 2 together at a time. Okay, which means I'm only looking at these 2. So what do they have in common? A y. Okay, what's left when you factor this y out? 2x plus 3. Plus sign, so no worries. Hey, these don't have any factors in common. If there's nothing else, remember there's always a 1. 2x plus 3. And we're back to that, hey, now I have two terms. Do they have anything in common? You bet. They both have a 2x plus 3. And what's left is y plus 1, right? If I took this 2x plus 3 out, there'd be a y. If I took it out of here, there'd be a plus 1. And now I have two things being multiplied together and only multiplied together instead of four things being added. Okay? So whatever this is being multiplied by this one thing. That's why it's important to keep those parentheses around there. It's saying, hey, this is one thing. 2x plus 3, whatever it is, it's one thing. Okay, let's try it again. Okay, do they have a common factor? 2, 4, 3. No. No B's over here. No A. No, don't forget to check that. So I'm going to group them. Okay. That means I'm only looking at this one and this one to start with. I can take a 2A out of both of those, and that leaves what? Right, an A there and a minus 2. Got a plus sign in the middle, so no worries. Here I can take out a 3B, and that leaves A minus 2. Well, here we are again with two terms. What do they have in common? The A minus 2. And then what's left, if you factor out the A minus 2 from each term? 2A plus 3B. Whoops. Okay. Here we go again. See what's different about this one. They still don't have any common factor, so that's not it. But when I group them into their groups, right, so I'm looking at what these two have in common, which is an x squared. Okay, there's an x left plus 3, but there's a minus in between here. Anytime we have negatives, we got to be careful, right? So really, remember, always factor out the negative. So I'm factoring this negative out. Not only the negative, but a 5. When you factor a negative out, it changes the sign of everything in here. Remember, I've factored the negative 5 out of here. So what's left is the positive x. I've factored the negative and the 5 out of here. So what's left is a positive 3. Because when you distribute this, it's got to wind up back being negative 5 minus 15. Okay, so be careful if you have a minus there in those terms, in between these two groups. Now, they each have an x plus 3 in common, so I'm going to factor that out. And then my remaining factor is x squared minus 5. All right, now there's just an overview of how to factor a polynomial with 4 terms by grouping. So if you want to pause it and read that, but that's the steps we were just doing. There it's just written out for you right here. Okay, factor by grouping. Let's try it again. So I'm going to group these together. Okay, these both have a 2 only that can be factored out. That leaves 3y squared minus 10w. Got a plus sign, so no worries. Let's see, what can I take out over here? Only a y, which leaves 15 minus 8w. Uh-oh. When I look at these two terms now, this isn't the same. Now be careful. That doesn't mean it won't factor. Although some things will not factor, just like some numbers will not factor, right? Primes. So not everything will factor, but don't give up yet. What you might have to do is rearrange it. Let's rearrange it and see if it looks like, let's put this y squared with this y, or that one, either one, right? Just rearrange it. And maybe this one has a w with that w. Okay, so let's try that. 6y squared plus 15y minus 20w minus 8yw. Okay, and now let's try to factor it with this arrangement by grouping. Okay, so here now I can factor out a 3y, and that leaves 2y plus 5. Careful, because there's a minus, so that means these signs are going to change. So I can factor out a 4w minus 4w, and that leaves, okay, negative 4 from negative 20 is 5, and the w's out here. Negative 8, take a negative 4 out, that leaves positive 2, the y, and the w's out here. Now look at these. They are the same thing, right? Because we keep saying 2 plus 3, 3 plus 2. Addition is commutative, right? The order doesn't matter. So these are really the same thing. I can factor out a 2y plus 5, which is what this is too, and it leaves 3y minus 4w. So even though in the form that they gave it to us, it wouldn't factor, it really was factorable. And we can multiply it out and check it and make sure we got the right thing if we're worried about it. All right, let's look at one more. Okay, one more. Okay, there's nothing in common here, so that means a 1 if nothing else. Here I can take out a 3. Okay, 4m minus n. But these are not the same thing. No, well, before we say it's prime, no, don't forget to try rearranging it. Which ones do you want to put together? Okay. So yeah, either this one with that one or that one, because I see an m and an m, and 9 and 12 have a common factor. And here's an n and an n, and 9 and 3. Okay, so let's do the 9mn minus 3n. And if you don't like that minus in the middle there, don't put that minus 4 first. I'm rearranging it after all, right? So make it easy on yourself. Okay, so let's try this order. Okay, now I can take out a 3 and an n, and that leaves a 3m minus 1. If I factor the entire thing out, don't forget I got to put that 1 as a placeholder. Now I got a plus, so no worries. What can come out of these two terms? A 4, and that leaves 3m minus 1. Hey, 3m minus 1 is the same in both terms, so that can factor out. And my other factor is 3n plus 4. Okay, make sure you understand this and you can do it well. Factoring by grouping. We're going to build and build and build on factoring. All right, let me know if you need anything.